All right, we're going to work through the analysis challenge question by question. The first question asks us to use the land fire existing vegetation type layer. So that's in here, and then from the other inputs folder, the NHD stream network that's been clipped down to this same area. All right, so the question is, what's the most common vegetation type within 200 meters of the stream network? And it tells us which field to pull the name from. So there's a couple of ways that I initially think of to go about this. My first thought is to create a buffer, a 200-meter buffer around the stream network, and then either use zonal statistics as a table to summarize the raster beneath it, or you could use that buffer to cut the land cover, which would give us a different way of approaching it. So let's just dig in and first create the buffer. I haven't adopted the pairwise yet. I don't think it makes any kind of difference for the outputs that we would get. I'm going to go ahead and dump everything in my default geodatabase. We want it to be 200 meters on either side. And we are going to dissolve this because otherwise every single one of these little stream segments is going to be its own little, balloon, and it's going to be a big mess. Okay, the buffer is complete, and we're going to evaluate it by grabbing our measure tool, and we're in metric. I'm just getting an idea. Okay, so it's about 400 meters across, meaning it's 200 meters on either side. That's what we want to see. Now, we could run zonal statistics as a table first to summarize these. Let's try that. All right, so remember, this is our zone data. Don't stop reading after raster. These are the areas that we care about, and so in this case, it's our buffer. Now, it's asking us what our zone field is, and I just want to make sure we talk about this really quick. If we look at the buffer attribute table, we only have the one shape, and that's because I dissolved it into one shape. So for us, we can just use object ID because there's only one record, and I'll show you an example of that when we get a little further down. But you can get individual, min, max, mean, standard deviation, zonal statistic for each feature, if that makes sense. Like we had the 50 meters, or we will have the 50 meters around each beaver dam. Then we want maybe to have individual records. Who knows? But for right now, we're just going to let it sit with object ID. But that's what that's talking about. It's going to treat all of the buffer as one feature. All right, the value raster that we want to summarize is our land fire data. I'm setting very bad examples, but I'm going to throw that in my catch-all. And that's fine. Okay, that all looks good. All right, when that's done, we can open up the results. Now, because this is land cover data, remember that, let me get in here and open this attribute table of the original land cover. So raster data sets are based on two fields, value and count. The value, cell value has to be numeric for rasters. All of these class names and existing vegetation type, fuel, all of these are appended afterward using a tool where you can append information onto a raster. We discovered in class last week, which is brand new to ArcGIS Pro 3, is that every time this data is manipulated, it's storing a history of the counts and the values for each, I guess, iteration of the data set. Okay, so our zonal statistics, using the 200-meter buffer around our stream network and summarizing the land cover. This is what we get. There's a count of quite a few cells. That's how many raster cells were summarized. The area is here, and we could divide this by 1,000,000. That's the conversion, and so we end up with 1407. And if we go into the attribute table here, I calculated the area in square kilometers, and it's around 1408 square kilometers. And so the area that was summarized looks good. Let's go back here to our zonal statistics. Okay, so that tells us that it's making sense. That's one way for us to evaluate it. Our minimum and maximum, these are the codes for land cover. Remember, going back in here, we've got these values of 30,001. And then we've got down at the other end, 9829. And that's what we saw in here. So that makes sense. That's our full range of vegetation that's in the original data set. Range means nothing, mean means nothing. I hope that it makes sense that we can't take an average of categorical values like this. The sum is just simply of all of these 1,500,000 cells, whatever these values are, they're added up. And so this is also meaningless. Variety could be meaningful in that it's telling us we have 166 unique values. So there are 166 unique land cover types. And if we were comparing watersheds, that might be an interesting value to take a look at. But these are the important ones for us, majority, minority. So it's telling us that the value of 7126 is the majority. It's the most common land cover type under the buffer. And so we can go back here to 7126. I could do a select by attribute, but I'm just going to scroll because they're sorted. So 7126 is this right here, the Intermountain Basins Montane Sagebrush Steppe. This is the most common land cover type within the 200-meter buffer. Now we could also clip this. Let's clear this. And we could use the buffer to cut the land cover. Let's try that. There's a couple ways. There's a clip tool, but you have to use the one that's in the data management. Clip analysis only works on vector data. You can clip raster. Oh, I guess they've changed it, which is pretty handy. They both used to be called clip. There's also a tool called extract by mask. Your mask is your buffer, and you're extracting the land cover values. Anyway, the raster we want to cut is this. Our output extent is going to be our buffer. We want to make sure we use the clipping geometry. Otherwise, you just get a rectangle back, and we don't want that. No data. I'm going to put in no data. Let's run that and see what happens. Okay, turn off our inputs, and we can see that we've got land cover that's just underneath the buffered areas. Let's close all these and get our attribute table for the clipped land cover open. And now we have a whole new set of values and counts in here. So we've got value and count 1, value and count 12, and then over here randomly a value and count 1-13. Those have zeros in them. Let's see here. So the count, if I summarize these, let's see here. The sum is just over 1 million, so 1.5 million. I'm just gonna write it down because I've got a bad memory. Let's close this and check out our second count. Has just over 6 million. And this one has, and remember the count is the number of cells that is sharing each one of those values. So I'm going to this, and the sum is 200 million. Okay, so the question is, what's the right number that matches the number of cells underneath our buffer area? Remember that we just looked at this. The buffer area was about 1,500 square kilometers. 1,400 square kilometers. So we'd want to find a sum from this clip table. We want to find a sum of counts when we multiply it by the area of a cell, which is 30 by 30 meters. They're 30 by 30. Ooh, that's ugly. Oh, that's awful. I'm not sure why it did that. I will have to do some digging why it changed the cells to slightly smaller and two slightly different sizes. Just makes me want to punch someone. Anyway, roughly a 30-meter cell. So if we multiply that and get 900 square meters, it's an estimate because our cell size changed just slightly. But what I'd want to do is figure out which one of those counts is closest to 1,500 square kilometers. So let me do a little math and I'll be right back. Okay, so I only had to do math with this first count. The first count was about 1.5 million cells. If I multiply that by 900 square meters, I get an area of 1,350,000,000. And if we convert this is square meters, so this ends up being 1,350 square kilometers in area, which is close considering our change in area and the difference between rasters and vector data. So this first one is correct. And then we can look at our count and sort it descending. And our most common cell value is the same thing, 7126. So we just verified that this Intermountain Basin's montane sagebrush steppe is the most common land cover type 2 different ways. I'm trying to think if there's another way I might go about this. I know some of you tried using summarize tools. I think some of you tried doing select by location. I tend to not use select by location on rasters very often. But if you got something different than 7126 and you think you've got a unique workflow that's legitimate, let me know. But that's it for question 1.